Good morning, students. Hope you are doing well. Today we start our first recorded session for the distance learning program, especially for IG students. In this session, we will solve past paper questions, and every day I will post a worksheet and recorded session related to this past paper questions. We start from the October-November series, and I took first question in this paper, and that question is related to the electronic configuration of elements. Okay, students, so first of all, what do you mean by periodic table? A periodic table is a chart that arranges all known elements in order of increasing atomic number. This is very important. How we arrange the elements in a periodic table? By the order of increasing atomic number. And what do you mean by atomic number? Atomic number is the number of proton in an atom. And a single atom is electrically neutral, so number of proton is always equal to the number of electrons. For example, if any atom has 6 protons, so it means it also have 6 electrons. Okay, it helps us understand properties of element, patterns and trends, and how elements react. Okay, so here is one another important term, that is mass number. What do you mean by mass number? Mass number is the proton sum of proton plus neutron. This is called mass number, and it is denoted by A, and atomic number is denoted by Z. Okay, students, here this is periodic table, and how we arrange the elements in the periodic table by the order of increasing atomic number. Here this one is vertical columns. These are called groups, and these are the horizontal rows are called periods. In the periodic table you have 7 periods and 18 groups. Here this is first group, this is called alkali metals. This one, the second group, is called alkaline earth metal. This portion, this is called transition metals, and after that you have boron family, then carbon family, then nitrogen, oxygen, fluorine, and fluorine, or you can say halogens family, and this one is your noble gases. Okay, how is it arranged? We already discussed this thing. We arrange the elements by the order of atomic number. Elements are arranged from smallest atomic number to the largest. For example, hydrogen 1, then helium 2, then lithium 3, like this. Okay, so next is periods. Horizontal rows are called periods, and how many periods in the periodic table? There are 7 periods. Electrons in the same period have same number of electron shells. I repeat this thing, this is very important. Electrons in the same period have the same number of electron shell. What do you mean by electron shell? Another name of electron shell is energy level. For example, this is an atom. Okay, these are called these are called electron shells are energy level. And if any atom have, if any two atoms in the same period, they have same number of electron shells. For example, I'll show you here. Here is example. For example, this is lithium. Okay, the atomic number of lithium is 3. So if you draw the diagram of lithium, it is like that. And you know, in first electron shell or first energy level, you can put only 2 electrons. So here is 2 electrons. Okay, and in the second shell you have 1 electron. Okay, so this is the diagram of a lithium. Okay, in the same period you have boron. If you draw the diagram of boron, what is the atomic number of boron? Is 5. So if you draw the diagram, it is like that. First electron shell, and this is the second one. In the first you have 2 electrons, and in the second one you have 3 electrons. So lithium and boron have same energy level, same number of electron shells, or same number of energy levels, same like this. Beryllium and carbon, nitrogen, oxygen, like this. In one period, if two atoms in the same period, they have same number of energy levels, or you can say electron shells. Okay, so next is groups. What is group? Vertical columns are called groups. How many groups in the periodic table? There are 18 groups in the periodic table. Elements in the same group have same number of valence electrons. This is very important. For example, if I draw a diagram of for one atom like this. So first of all, what do you mean by valence shell. The outermost shell is called this one. The outermost shell is called valence shell, and the electron present in valence shell, these are called valence electrons. So elements in the same group have same number of valence electrons. Next thing is elements in the same group have similar chemical properties. What do you mean by chemical properties? Chemical properties means how one element reacts to other elements. These are called chemical properties, and chemical properties depends upon valence electrons. For example, group 1 very reactive metals, group 17 very reactive non-metals, group 18 noble gases very unreactive. Okay, students, now we can see here how group number tells us the number of valence electrons in an atom. For example, this is sodium. What is the group number for sodium? Group 1. So if I ask you how many number of electrons in their valence shell, so there is one electron in their valence shell. Next, for example, this is calcium. If I ask you how many electrons in their valence shell, what is the group number for calcium? Group 2. So there are 2 electrons in their valence shell. Okay. Okay, so next thing is we divide the periodic table into two subgroup. Subgroup A, okay, and subgroup B, like this. Look, this is 1A, this is 2A, then this is 3A, then this is 4th A, then this is 5th A, 6A, 7A and 8A. Okay, and this portion is subgroup B. Basically this portion is also called transition elements. Okay, and this the subgroup A, mostly we call it normal elements. In general, we can discuss the properties of a normal elements. Okay, so that's why we divide the periodic table into two subgroups, subgroup A and subgroup B. Why explain you this thing? Because student, here this is 1A, 2A and directly jump to the 3A. But in journal, when we discuss in a journal, this is basically a 13 group. This is 14 group. This is 15. This is 16. This is 17, and this is 18 group. If I ask you how many valence electrons in carbon, so what is the group number for carbon? According to the subgroup, there is a 4th A. So 4 means this, the group number is 4th. So that's why there are 4 valence electrons in carbon. Same like here oxygen. What is the group number for oxygen? 6A. So it means oxygen has 6 electrons in their valence shell. Okay, students, clear? Okay, so next is type of elements in periodic table. So we have three types of elements. The first one is metal, non-metal and metalloids. Metal is present on the left side here. These are the first two group is your metals, and this one is called, and after that you have transition metals. After metals you have non-metal. This one, the left side is your periodic table is called is non-metals. This one, okay, and the last one is metalloids. Metalloids is a along a zigzag line like this one. This is boron, silicon. Okay, this is your metalloids. Okay, so you can memorize here. You can memorize the position of the elements where metal is present in the periodic table, where non-metal is present in the periodic table, and where metalloids are present in the periodic table. Okay, so here is the summary of the periodic table, and that is very important to solve past paper questions. The two most important things that we already discussed. The first thing is period number. Period number tells us electrons, number of electron shell in an atom, and the second thing is group number. Group number tells us number of valence electrons in an atom. So here is student group 1. What is the name of the group 1? Alkali metals. The type of element is very reactive metals. The common ion charge is +1. Example is lithium, sodium and potassium. I explain you why this is +1 in the next slide. Next, group number 2. What is the name of the group number 2? This is called alkaline earth metals. The type of elements is very reactive. Common ion charge is +2 and the example is magnesium and calcium. Then 3 to 12 transition metals, hard, strong metals, and the common ion charge is, here is the oxygen state, or common ion charge is variable like iron, copper, zinc. Then you have 13 group 13. This is boron group. Okay, and in this group you have metal plus metalloid. And what is the common ion charge? This is plus 3. And the example of elements is boron and aluminium. Then group 14, this is group carbon group. Okay, the common ion charge is plus 4. This common ion charge is very important. Then carbon, silicon, then nitrogen group. Okay, mostly now from the group 15 we start, there is a starting of a non-metal. They are mostly non-metals. Okay, the common ion charge is minus 3, and the example is nitrogen and phosphorus. Group 16 oxygen group. Okay, reactive non-metals, the charge is minus 2, oxygen and sulfur. Then the group is 17, this is called halogens, very reactive non-metals. The charge is minus 1, fluorine, chlorine and bromine. Then there is group 18 noble gases. Okay, and it is also called inert. Inert means unreactive. And what is the common ion charge? 0. Why it is 0? Because their valence shell is complete. In their valence shell they have 8 electrons, so that's why the charge is 0. The example is helium, neon and argon. Okay, so next is, what is electronic configuration? Electronic configuration is the arrangement of electrons in shells around the nucleus. Electrons fill shells in order. In first shell there is maximum 2 electrons, in second shell 8 electrons, in third shell 8 electrons. For example student, there is one atom that is called magnesium, and the atomic number of magnesium is 12. If I ask you, please draw the diagram for magnesium. So first of all, magnesium belongs to period 3. So in magnesium you have 3 electron shell. So like this you can draw first shell, second and third. After that you can arrange the electrons in shells. In first shell you have 2 electrons. Okay, because you can maximum enters 2 electrons in the first shell. In the second shell you have maximum 8, so here is 8. And in the third shell you have maximum 2, so this is like that, 2, 8 and 2. So this is called electronic configuration. In simple words, a range of electrons in shells around the nucleus. Okay student, next is outer shell electrons. Another name of outer shell electron is valence electron, and this is very important concept we already discussed. For example, I draw a diagram of an atom here. This is first shell, this is second shell, and this is a third shell. Period numbers tells us the number of electron shells in an atom. So for this atom we have 3 shells, so this atom belongs to period 3. Okay, next thing student, this outermost shell is called valence shell, and the electron present in valence shell is called valence electrons. This valence electron is very important. Why? Because outer shell electrons or valence shell electrons determine 3 things. The first thing is group number, the second thing chemical reactivity, and the third thing is type of ion formed. Very important. For example, I take an example. For example, sodium. The atomic number of sodium is 11. Okay, write the electronic configuration of for sodium. In first shell you have 2 electrons. Okay, in the second shell, how much you can maximum put? 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 2 plus 8 is 10. How much is left? Only 1. So write here 1. Okay, so now listen carefully. Outer shell electrons determine group number. If I ask you what is the group number of sodium, how many electrons in their valence shell? Only 1. So for sodium the group number is 1. Group number is 1. Is it clear? Okay. Next thing is student, what is the type of ion that is formed sodium? This thing is very important. Student, there is one rule, this is called octet rule. According to octet rule, all the elements wants to get 8 electrons in their valence shell. All the elements wants to get 8 electrons in their valence shell. They can get this 8 electrons maybe by lost the electrons or by gain the electrons. For example, in case of sodium, we can understand In case of sodium, how many electrons in their valence shell? Only one. How much it needs to complete their octet rule? Sodium needs 8 electrons. So it's very difficult to take 7 electrons from any other element. So what sodium do? Sodium lost this 1 electron. When sodium lost 1 electron, we know when any atom loses 1 electrons or like lose electrons, it has positive charge. For sodium is Na plus. Is it clear? For example, I erase this one, the outermost shell. Okay, because sodium lost one electron from their outermost shell. Now how many electrons left in their valence shell? Now this is the valence shell. Okay, and how many electrons in their valence shell? 1, 2, 3, 4, 5, 6, 7, 8. So now sodium is stable. This is called octet rule. We can get another example. For example, magnesium, and I ask you, what is the charge on, what is the type of ion formed magnesium? What is the atomic number for magnesium is 12. The atomic number for magnesium is 12. So draw a diagram for magnesium. Okay, here for example this is the diagram of magnesium. Okay, second shell and third shell. In first shell you have 2 electrons, second shell 8, 1, 2, 3, 4, 5, 6, 7 and 8. 2 plus 8 is 10. 2 is left, so 1 and 2. First of all, if I ask you what is the group number for magnesium, how many electrons in their valence shell? 2. So for magnesium the group number is 2. If I ask you what is the period number for magnesium, how many electron shells is there? 1, 2 and 3. So for magnesium the period number is 3. Okay, now student listen carefully. How many electrons magnesium needs to complete their octet? Octet means in the valence shell atom has 8 electrons. It needs 6 electrons. So again it is difficult to take 6 electrons from any other element. So what magnesium do? Magnesium lost these 2 electrons. Lost these 2 electrons. When magnesium lost these 2 electrons, so on magnesium have plus 2 charge, plus 2 charge, and when you remove these 2 electrons, so check how many electrons now in this now this one is the valence shell, and how many electrons in their valence shell? They magnesium have 8 electrons in their valence shell, so magnesium complete their octet and now magnesium is stable. So like this student, atoms can be maybe lost, okay, and maybe gain electrons according to their requirement. Okay, so next is we already discussed this thing. In periodic table we have two subgroups, subgroup A and subgroup B. For subgroup A we use Roman symbols. For example, if there is group 1, so how many electrons in their valence shell? 1. For group 2, 2. For group 3, 3. For group 4, 4. Group 5, 5 and so on like this. Okay, so important rule, group number means the outer shell electrons, or you can say the valence shell electrons, and period numbers means number of electron shells. For example, if any atom their electronic configuration is 2a2, so how many shells in their atom? There are 3 shells. And if I ask you what is the group number for this atom, the group number is 2. Why 2? Because in their valence shell they have 2 electrons. Next, there is one group in the periodic table that is called noble gases. Noble gases is group 18 in general, and in subgroup this is group 8. Noble gases have full outer shell. It is very stable. Why it is very stable? Because they have complete outermost shell, so that's why it is very stable. Full shell means in the first shell they have 2 electrons, and in the outer shell they have 8 electrons. And if I ask you what is the reason for stability, the reason for stability is full shell and no low energy state. Okay, so next is metal versus non-metal. Metal is present on the right side of the periodic table and non-metal is present on the left side of the periodic table. In case of metals, you in their valence shell, metals have mostly 1, 2 or 3 outer electrons, and that's why it lose electrons and form positive ions, and it is good conductor of electricity. Like for example, this one for magnesium. Okay, in case of magnesium lose 2 electrons and becomes 2 8, and you know, when there is 8 electrons in the valence shell, this is called octet rule. This is called octet rule. Next is student non-metals. Non-metal mostly have 5, 6 or 7 outer electrons. Okay. In case of non-metals, it can gain electrons, and you know, when any atom gain electrons, they have negative charge. They have a negative charge. When any atom lose electrons, they have positive charge. When any atom gains electrons, they have a negative charge. So they mostly gain electrons and form negative ions. Okay. Okay, so next thing is formation of ions. This thing is depends upon the requirement of an element. Atoms reacts to get a full outer shell. For example, in case of metals, we already discussed. In case of metals, we have 1, 2 or 3 electrons in their valence shell. So metals loses these electrons, and in their remaining shell they have 8 electrons. And you know, when there is when any atom in their valence shell they have 8 electrons, the atom will be stable. So that's why metal can lose 1 electrons, maybe 2 or maybe 3 according to the requirements. So it can forms +1, +2 and +3. But in case of non-metals, it can gain electrons. Okay, and it can forms negative ion like -2, -1, -3, like that. For example, 2, 8, 6. Okay, in this case, the atoms can gains 2 electrons. When it can gains 2 electrons in their valence shell, they have 8 electrons. And you know, when in the valence shell they have 8 electrons, it can be stable. So it forms a 2 -2 ion. Okay. Okay, so last thing is stability rule. The golden rule is atom reacts to achieve full outer shell. Maybe it is 2 or maybe it is 8. 2 is only for hydrogen and for lithium. This is exceptional case for only hydrogen and lithium. For other elements, it will be 8. This is called stable electronic configuration, and this is also called noble gas configuration. Why? Because in case of noble gases, all the noble gases have their complete valence shell. So that's why atoms wants to achieve electronic configuration same like for a noble gas. Okay students, so this is for today lesson. You can watch this video carefully, and after that you can solve the worksheet that I will share with you. Goodbye.